joint CDF or PDF or whatever the probability function. However, in order to describe this x and y, the relation of the x and y, if we so all the time if we use this CDF or PDF, it's too much complicated. So people need one simple value, one simple number that represent the relation between x and y. That number is covariance. That number is covariance. So covariance is simply describe the relation between x and y. 아시겠나요? 자, 다시 설명하면은 네, 여러분 expectation 뭔지 아시죠? 랜덤 베리어블 x가 있어요. 그럼 expectation은 얘가 얼마지? 라고 사람이 물어봤을 때 얘는 1이야 혹은 2야 라고 말을 해주기 위해서 우리 사실은 1도 아니고 2도 아닌 거 알고 있죠. 왜냐면 얘는 변하는 값이니까. 근데 단순히 사람들한테 편하게 전달하고 얘가 뭔지를 인투이티브하게 알 필요가 있을 때 우리가 1 이런 말을 쓰는 거죠. 그게 expectation. 근데 얘는 변하는 값이니까 얘가 얼마나 많이 변하는지를 우리가 알고 싶어요. 그것도 이 PDF나 CDF에 의해서 완전하게 우리가 완벽한 정보를 줄 수 있지만 너무 복잡하니까 베리언스가 1이야. 이런 식으로 하면 얘는 1만큼 변하겠구나 라고 우리가 이걸 인투이티브하게 알 수 있죠. 마찬가지로 x랑 y가 있을 때 x랑 y의 관계가 있어요. x랑 y는 서로 어떤 관계를 맺고 있는데 그 관계는 뭐 지금까지 우리가 봤다시피 조인트 CDF나 PDF를 예, 그 넷마 예, 얘 무슨 뭐 개그 콘서트도 아니고 네. 예, 어쨌든 네. 자, 핸드폰 네. 네, x랑 y의 관계가 이제 조인트 CDF나 PDF에서 완벽하게 이제 묘사가 돼요. 하지만 아시다시피 수식이 복잡해요. 그러니까 사람들이 필요한 거야. 얘네 사이의 관계가 뭐지? 를 한 번에 나타낼 수 있는 딱 한 숫자가 뭐냐 하면은 바로 코베리언스다 라는 의미입니다. Okay? Okay, so this one is what I explained. So sometimes if x and y's covariance is 0, so we say x and y are uncorrelated. In Korean, 상관관계가 없다 라고 말을 하는 거죠. So zero means, okay? So if it's okay, so we're gonna see in this one later. Okay, then look at the sum of the property of the covariance. First of all, covariance of ax plus b and cy plus d. The covariance of this one is, so by the definition of the covariance, by the definition of the covariance, it is covariance of ax plus b minus expectation of ax plus b times cy plus d minus expectation of cy plus d. Okay? But in here, so as you see here, this b here, this b and this b are cancelled out. Because the expectation of ax plus b is a of expectation of x plus b. And here, this d is also cancelled out. So finally, it becomes covariance of, and here a and a, so a times x minus expectation of x times c here, c times y minus expectation of y. So finally, it is AC times covariance of x and y. That means it is scaling only property. So it doesn't, affected by the adding some, the constant B and D. So only the scaling A and C are important factor. So it is similar to the variance, right? So the variance of AX plus B is given by A square of variance of X. So this B doesn't affect the variance. So the covariance is also means how much it varies. So it doesn't affected by the shift. Okay. So here, and one more thing is, how about the covariance of the same random variable, X and X, covariance of X and X. So in this case, Y is equal to X. In this case, by definition, expectation of X minus mu X times X minus mu X. So this is a variance of X. So covariance of the same thing, same random variable, that's just equal to the variance of X. Okay, so here is some important interpretations. So again, I say the covariance is how much two random variables varies together. That means, in other words, how much variance two random variables actually share together. So if it's the X and Y are the same random variable, then the amount of the shared the variation is equal to the variation of the random variable itself. So that's why covariance of two x's becomes just variance of x. 그러니까 다시 말하면은 그 코베리언스는 다시 이야기하지만 얼마만큼 x랑 y가 같이 변하냐는 뜻인데 x랑 y가 같은 변수예요. 그러면은 항상 같이 변하잖아요. 그럼 그 변하는 정도가 x의 베리언스랑 베리언스잖아요. 그러니까 코베리언스가 x의 베리언스로 주어진다는 뜻이죠. 그러니까 이렇게 해석이 된다는 뜻입니다.
아까 코릴레이션이 영향은
네.
서로 상관관계 없다고 하셨는데
네.
혹시 마이너스하면은
예. 그러니까 그거에 대해서 좀 설명을 드리면은 okay, so let me explain about the covariance and the actually okay, so I will explain this one a little bit later. 조금만 이따 설명드릴게요. 요 correlation coefficient까지 설명드린 다음에. Okay. So here we learn the concepts of okay, so here is important. There's a covariance x and y, and this is expectation of xy minus ex ey. Okay, and here is another thing, correlation of x and y. This is a correlation, which is expectation of xy. Here we introduce new, how can I say the new term? That is a correlation coefficient. Correlation coefficient. We often denote with rho x and y, which is defined by in this way. So that is covariance of x and y divided by square root of variance of x and variance of y. This is the definition of the correlation coefficient. So we have the three terms: covariance, correlation, and correlation coefficient. But this, the correlation coefficient, we often called by Pearson's correlation coefficient. because there's another guy, Spearman. Spearman also developed another type of correlation coefficient, but in order to the distinguish with the Spearman's version, so we sometimes call it the Pearson's correlation coefficients. But in many cases, if we omit that, if we just say correlation coefficient, that means this Pearson's correlation coefficient. Okay, so actually, in many cases, correlation coefficient is more referred than the covariance or correlation itself, because importantly, this correlation coefficient is limited by between -1 and 1. So this covariance and correlation can be negative infinite or positive infinite. It can be vary from negative infinite to positive infinite. However, this correlation coefficient is limited by -1 to 1. So that's quite important stuff. So it's like that. So if this if x and y are vary together a lot, then this covariance can be increased without limit. So it can be 100, it can be the 1,000, it can be the 10,000 or million. However, correlation coefficient is limited by 1. So it has some maximum limit. So now we can say, okay, if it's close to 1, it is really highly correlated. However, with this covariance, even though it is large, it's very difficult to say whether it's they have a high correlation or not, because it's not limited. Okay, so this is the very important property. So let's see how we prove this this limitation of the correlation coefficient. What's that? Let's use it. Okay, let's think about W is x minus ay. So W is the random variable derived from x and y throughout this function. Okay? Then here we want to calculate the variance of W. So variance of the W is variance of x plus variance of ay, which is a square variance of y, and minus 2 times covariance of x and ay. So we know how we can derive this relation, right? And this a can be get out, so it is 2a of covariance of x and y. Okay, so let's rewrite. But importantly, this W, the variance of the W should be non-negative. Should be non-negative. So it is should be larger than or equal to 0. Okay. Then from this the relation we can get the relation that 2a times covariance of x and y. Let's use the simple terms. So we use this one is the variance of x square, and this is the variance of y square, and this is the covariance of x and y. We use this sigma to notation. Then 2a times sigma xy is less than or equal to sigma x square plus a square sigma y square. Okay, this is the relation we derive. So we just replace the variance to the the sigma x square and the covariance as sigma xy. Okay, here if we put A is equal to sigma x over sigma y, then 2A times sigma x over sigma y should be less than equal to square plus sigma y square sigma x square over sigma y square times sigma y square. Okay? No. Here is, we should use sigma x over sigma y times sigma xy. So we know, we can find out this relation here, right? And in here, let's see. And in here, so this term is become to 2 sigma x square. 2 sigma x square. So here, so that means here we have this 2 is gone on the both sides, and this sigma square is gone. Okay? 뭐요? 어떤 게 타이포예요? 시그마 저게 xy 제곱이 돼야 되나? 어떤 게 지금 타이포라는 거예요?
x제곱, 시그마 xy 제곱.
요거요? 예, 그쵸. 요게 지금 제곱이 돼야 돼야죠, 당연히. 예. 그리고 요거는 시그마 x 제곱이 돼야 되고. 그쵸? 네, 맞아요. 요게 시그마 x 제곱. 예, 이거 타이포죠. 이거 시그마 x 제곱 돼야 되고, 이거 시그마 a 스퀘어 플러스 시그마 y 제곱이 돼야 돼야죠. 네, 타이포. Okay, so up to this point, so if we summarize this one, it becomes sigma xy divided by sigma y should be less than equal to sigma x. Okay, and from here we say sigma xy divided by sigma x and sigma y is less than equal to 1. And this one, sigma xy divided by sigma x and sigma y, this is the correlation coefficient. So again, correlation coefficient definition is, let me write here, sigma xy, correlation coefficient is covariance of xy divided by square root of variance of x and variance of y. That means covariance is denoted by sigma xy divided by variance is sigma square of x and square root of this sigma x. Similarly, sigma y. So this one. So this is the correlation coefficient. So here we prove that correlation coefficient should be less than equal to 1. Okay? So similarly, if we put the minus 1, no. If we say the A is equal to minus sigma x over sigma y, then we can prove that correlation coefficient should be larger than or equal to minus 1. Okay? So basically, this correlation coefficient should be between minus 1 and 1. That is important. That is important factor. 자, 여러분 우리가 correlation coefficient에 대해서 이야기했는데 correlation coefficient는 다시 말하지만 우리가 여기서 증명했지만 마이너스 1과 1 사이에 있어야 돼요. 아시겠나요? 네. Okay, so let's check some of the important stuff of the correlation coefficient. Let's think about again the correlation coefficient is defined by C of V of xy divided by square root of variation of x and the variation of y. So first, let's think about how about the correlation coefficient between ax plus b and how can I write this? Okay, so let's use correlation coefficient of ax plus b times and cy plus d. So x is scaled by a and moved and shifted by b, and y is scaled by c and shifted by d. So let's find out this one. First, the covariance, this one and this one, is given as AC times covariance of x and y. And how about the variance of ax plus b? That is a square times variance of x. So this is square of a square times the variance of x. And also, y case, this is a c square of variance of y. So here, this AC cancelled by a square and the c square. So remaining stuff is just correlation coefficient of x and y. So that means correlation coefficient is scale free actually. It doesn't affected by scaling factor a and c. Of course, it is shift free. It doesn't affected by b and d. Okay. So here, this is the why why people like to use correlation coefficient instead of the covariance. So in order to represent how much the x and y varies together, okay? So we can use covariance. However, in this case, if a and y is scaled, this covariance also scaled by a and c. Scaled by affected by this scaling factor. That means usually let's think about x is height and y is weight. Usually they have some correlations. If x increase, y also increase together. If height increase, then weight is also increased together. However, if we measure their relation with the covariance, it is really highly affected by units. If we measure the height with the centimeter versus if we measure the height with the meters, it's the 100 times difference. Actually, the actual factors, actual data has no change. However, by changing the unit, the scale is different. That means covariance changed by 100 times. However, the correlation coefficient between yes.
Can you explain it one more time, the last part?
Okay. Okay, here. Okay, let's think about let's think about we want to measure the covariance, or we want to investigate the relation between weight and height. Okay, so in order to represent the relation between W and H, we can actually calculate covariance between W and H. That covariance is between like this. let's think about this is 1. Let's think about this is, let's say, the 0.5. Okay? Let's assume that this is 0.5. But, we have to define, what you want to know is, this 0.5, what's the meaning of this 0.5? It's really hard to, interpret this 0.5. Because the reason is, okay, let's think about this height is measured by meter. And this height, weight, no, let's check. This height is measured by meter, okay? But if we change the unit to the centimeter, then height become 100 h by changing the unit to the centimeters. Then in this case, covariance between W and 100 h is become how much? How much? 50. So actually, we are handling the same data, weight and height, just by changing the unit. This covariance changes a lot. So it's really difficult to say what's the meaning of the 0.5 and what's the meaning of the 50. However, if we use the correlation coefficient, W and H, if W and H coefficient, let's say, is 0.7, then correlation coefficient of W and 100 H is also 0.7. So it is scale-free. So it's independent to the units. So we can actually look at the data as it is. So that's why the people like to use this correlation coefficient instead of covariance. Okay. Okay, here let's look at some of the stuff. Okay, let's think about what could have the correlation coefficient of between 2x, x and x. What's the correlation coefficient of x and x? Let's calculating the correlation coefficient between two between the same random variables. This is so the covariance of x and x become variance. So it's a variance x and square root of variance x times variance x means variance x squared. So it's 1. So this the maximum correlation coefficient. So the 1 is the maximum value. That means if they are the same variable, that means they perfectly vary together. In that case, it achieves 1. So the meaning of the correlation coefficient is 1. That means they are exactly varies together. Okay, so how about the x and minus x? Between x and minus x. X and minus x. Minus x. Then this the denominator is the same because variance of the minus x is a variance of x, right? So how about this covariance stuff? Numerator is the covariance of x and minus x, which is minus covariance of COV of x and x, square root of variance of x squared. It is minus 1. So x and minus x, if you think about x and minus x, they are actually perfectly tied together, right? But that's just the negative sign. So if x become 1, minus x become minus 1. So they are perfectly tied, but they just change it to the negative, the other directions. That means they are have the the lowest, smallest correlation coefficient. So minus 1 means two random variables are perfectly varies the opposite directions. So here, by using the the correlation coefficient, we can define what's the perfect correlations. This is 1 or minus 1. 자, 다음으로 넘어가서 okay, so this is the very important stuff. So as I said, the correlation coefficient is kind of the relative covariance to the variance. In other words, correlation covariance of x and y is covariance of x and y divided by variance of x and variance of y. This covariance is scaled by standard deviation of x and standard deviation of y. So it is kind of the relative covariance to the variance of x and y. So that means, okay, so let's think about the x. So relation between x and y1. So the relation between 네? 네.
질문 있어요.
Like on the previous example, like if you replace minus with c constant, where c is minus 1, and then the correlation is like scaling free, right?
Right.
그러면 똑같아야 되는 거 아니에요? minus c랑
Scale. Okay, so here scale free means the scale. So in here, when I say scaling means the absolute value. So if we put a minus, the change becomes totally opposite.
근데 마이너스는
네,
c랑 콘스탄트로 바꿔서
네.
쓰게 되면 스케일링 프로퍼티를 쓰면
그러니까. Okay, so let me get back. Okay, again, so let's think about sigma. So let's think of the correlation x and
c of
let's say a of x. A of x. Then I become a times covariance of a times okay, so let me get back. Covariance of x and ax divided by square root of variance of x times variance of ax. Okay? So here, a times covariance of, so the covariance becomes the variance of x divided by, in here, this is square root of a square times variance of x. You got it? So, what's the square root of a square? If a is negative, minus a. Okay? Okay, so that's the answer. No problem. Okay, so anyway, so let's think about, we want to compare x with y1. So we want to to find out the correlation or some relation between x versus y1, and we want to compare this relation with x versus y2. So here what you want to find out is whether when you compare x with y1 or when you compare the x with y2, which one has which y has more related to x. That's in general questions, right? So in order to answer that question, if we measure the correlation coefficient, covariance x and y1 and And let's think about we calculate covariance of x and y2. In here, even though the covariance of x and y1 is larger than covariance of x and y2, it is very difficult to say x1 is more related to the y1 because of the scaling effect, right? So if we just say, instead of y2, if we use, the 100 y2, then this one becomes 100 covariance of x and y2. So then in this case, it might be larger. They don't become even larger. So in terms of interpretation, it's really hard to say that the large covariance means larger relations between x and y. So it's really hard to say. However, in terms of the correlation coefficient, because they are scaling free, when we measure the correlation coefficient of x and y1 and x and y2, if correlation coefficient of x and y1 is larger than correlation coefficient of x and y2, then we can definitely say, okay, x and y1s are more correlated than x and y2. So x is more correlated to the y1 than y2. We can definitely say with these relations because this is scaling free. Okay. So actually, this one actually shows the very important concepts between covariance and the correlation coefficient. In here, R means correlation coefficient and C of V means covariance. Okay, so let's think about x and y. If they actually distributed in this way, in this region, that means if x varies to 1 to the positive and y also varies to the positive because they have the high probability on this side. If x becomes smaller, negative, and y also become negative, so they are located here. So if x and y are distributed in this way, then we say, okay, they have high covariance and high correlation coefficient. Then we say they are highly correlated. Okay, the other way around. When x is become positive, y become negative. Or y become positive and x become negative. So they are something like this relations. Maybe x is the time for the playing computer game and y is your score, test score. Then they're gonna have a negative relation. If x is the starting time, then they have the positive correlation. So in this case, if we measure the covariance or the correlation coefficient, they have the negative values. But sometimes people say they have some, but usually people do not say they have the low correlation or low covariance. Instead, they say, okay, in this case, they have negatively high covariance or negatively high correlation. Because here the correlation or covariance means how much they are varied together. That's actually important step. So in this case, they are quite tied together, right? But their direction is the other direction, the opposite. So in this case, people usually say, okay, they have negatively high covariance or negatively high correlation coefficient. In contrast, this one is high correlation, high covariance, or positively high covariance and correlation coefficient. So we say they have the positive correlation and this one have the negative correlation. So what's the meaning of the no correlation? That means uncorrelated or C of V is 0. If it's like this, so we say they have the low correlation or low covariance. That means even though when x is positive or negative, the variation of the y is not much related. So there's no the not much things, the varying together because they are, just, distributed, right? So in this case, we say low correlation and low covariance. Okay? So if we summarize it, okay, so covariance case, they can be minus infinite and positive infinite. Okay? And correlation coefficient, their minus limit is -1, positive limit is +1. So bicentered 0. And here we usually say if these values are close to positive infinity or positive 1, then we say they have high covariance or highly correlated. And we say here positively. Positively. If they are close to the minus infinity or -1, we also say, so here high means they are buried together. That's the meaning of the high. So they also have the high correlation and covariance and the correlation coefficient in terms of negative. So we say they have low correlation. That means X and Y do not tend to vary together when this covariance or correlation close to 0. So this is low correlation and low covariance. Okay, so this is the concept of the high and low correlation and covariance. So importantly, let's look at this one. Let's look at this one and compare to this one and this one. They have the same shapes. However, only different thing is scale. This is scaled by 0.1, and this is scaled at 1. That means, in terms of covariance, this one has a smaller covariance, low covariance. So this one is close to 0 actually, right? So, but this one and this one, they are actually representing the same relations. So covariance cannot be used. Instead, if we look at the correlation coefficient, this one is also high. This one is also high. So here we can say, okay, they have high correlations. So this is the quite important concept of the correlation and the covariance. 자, 여러분 이해가 되시나요? 코렐레이션과 코베리언스의 관계에 대해서? 아까 한 것에 질문이 대답이 됐나?
약간 됐는데.
네, 아까 뭐였죠? 네.
아니, 그 마이너스랑
네.
플러스랑
네.
서로 연관이 있다면 굳이 왜 마이너스를?
아, 그러니까 마이너스의 의미는 예를 들면은 그러니까 상관계가 있다 없다인데, 그러니까 아까 저랑 똑같은 거죠. 예를 들면 내가 공부한 시간과 성적은 공부한 시간이 커지면은 성적도 올라가잖아요. 그러면은 걔는 상관계가 있어요. 하지만 포지티브하게 있다. 네? 내가 게임한 시간과 성적이다. 그러면은 게임한 시간이 늘어나면 성적이 떨어지잖아요. 예, 그러니까 그거를 구별하기 위해서 마이너스를 붙이는 거죠. 네, 그래서 양의 상관관계냐, 음의 상관관계냐. 아, 물론 게임을 한다고 해서 내 성적이 꼭 떨어지는 거는 떨어지죠, 꼭. 네, 네, 꼭 떨어지죠. 네, 네, 그래서 뭐 여러분이 아마 뭐 신문 기사나 뭐 일반적으로 쓸 때 얘네는 뭐 양의 뭐 상관계가 높다, 뭐 양의 상관계가 있다, 음의 상관계가 있다 이런 말을 들을 텐데 그게 요거 의미예요. 네, positively correlated 하냐, negatively correlated 하냐라는 뜻이죠. 이게 지금 보면은 그러니까 데이터 분석을 할 때 이게 가장 기본이 되는 거예요. 기본적으로 이제 x와 y가 두 개의 변수가 있을 때 얘네가 상관이 있냐 없냐. 그냥 correlation coefficient가 0에 가까우면 상관이 없는 거고 0보다 1이나 마이너스 1에 가까우면 상관이 있는 건데, 그러니까 얘네가 양의 상관계가 있냐, 음의 상관계가 있냐. 이걸 분석하는 게 가장 기본적인 일이죠. 네, 그래서 오늘은 여기 correlation, covariance까지 하도록 하고요. 혹시 질문 있으신가요? 네, 질문 없으시면 네, 수고 많으셨습니다. 네, 그 뭐지 성적 여기 있구나. 네.